Hello everyone and welcome to our course on dynamic Excel reports for marketing analysis. In this course, we will explore Microsoft Excel and learn how to use it to build dynamic reports for marketing analysis. Today, we will begin by understanding the basics of marketing analysis, its significance in data-driven marketing, and its practical applications in the real world. First, let's define marketing analytics. Marketing analytics refers to the processes and technologies that enable marketers to evaluate the success of their marketing initiatives. This is achieved by measuring performance using key metrics like ROI, which means return on investment, also the engagement rate and conversion rate. Now, let's look at the key components of marketing analytics. These include collecting data from various sources, such as website traffic, social media platforms, and CRM systems. By analyzing and interpreting this data, marketers can gain actionable insights, which allow them to make informed decisions and enhance their marketing strategies. Next, let's explore the importance of data-driven marketing. The significance of data-driven marketing cannot be overstated. By leveraging data, marketers can make decisions based on evidence rather than intuition, which significantly improves the effectiveness of their campaigns. Additionally, analytics enables personalized marketing efforts, allowing for tailored campaigns that target specific audience segments. This leads to more efficient resource allocation, as marketers can identify high-performing channels and campaigns. Ultimately, businesses that effectively utilize data gain a competitive advantage over their competitors in terms of customer engagement and return on investment. Furthermore, marketing analytics facilitates the measurement and optimization of campaigns, helping to refine strategies for even better results. Now, let's discuss some of the real-world applications of marketing analytics. In the real world, marketing analytics has numerous applications. For instance, it can be used to track the performance of social media campaigns by measuring metrics like engagement, impressions, and click-through rates. It also helps in understanding user behavior on websites through tools like Google Analytics, providing insights into how visitors interact with the site. Additionally, analyzing CRM data can enhance customer segmentation and retention strategies, ensuring that businesses can effectively cater to the needs of different customer groups. Moreover, marketing analytics enables the calculation of ROI for ad spend across various platforms, such as Google Ads and Facebook Ads, helping businesses optimize their advertising budgets. If some of the terms mentioned here are new to you, don't worry. As we progress through the course, I will define most of them. In conclusion, marketing analytics is a powerful tool that allows businesses to evaluate and improve their marketing efforts through data-driven insights. By understanding its components, the importance of data-driven marketing, and its real-world applications, you will be better equipped to create effective marketing strategies and achieve greater success in your campaigns. We will dive deeper into all of these concepts in our upcoming lectures. Thank you for following this one, and I'll see you in the next lecture. Hello everyone, and welcome to this lesson as part of our ongoing course. In this lesson, we'll explore the different types of marketing data, the importance of integrating these data types, and the challenges associated with managing marketing data. Let's begin by discussing the various types of marketing data. First, we have digital data. Digital data is one of the primary sources encompassing website analytics, social media platforms, and search engine metrics. Examples of digital data include page views, bounce rates, click-through rates, and impressions. This type of data is crucial for tracking the effectiveness of digital campaigns and optimizing the user experience. Next, we have CRM data, which stands for customer relationship management data. This data is gathered from platforms like Salesforce and HubSpot and includes customer contact details, purchase history, and interaction logs. CRM data is instrumental in building comprehensive customer profiles, segmenting audiences, and enhancing customer retention strategies. Following that, we have sales data, which is another essential category sourced from point-of-sale systems, e-commerce platforms, and accounting software. This data includes metrics such as revenue, order volumes, and average order value. Sales data helps businesses measure performance and identify emerging trends. We also have campaign data, which is collected from advertising platforms like Google Ads and Facebook Ads Manager. It includes budget details, ad impressions, cost per click, and conversion rates. Campaign data is vital for evaluating the return on investment from marketing campaigns and refining ad strategies. Understanding the importance of integrating these different types of data is crucial for effective marketing. By combining data from various sources, we gain a holistic view of marketing performance, providing a complete picture of how our efforts are paying off. Moreover, integrating data offers cross-channel insights, allowing us to understand how different channels influence each other and enhance our multi-channel strategies. This, in turn, leads to better decision-making, enabling more effective prioritization of resources and strategic focus. However, managing marketing data comes with its own set of challenges. One major issue is data silos, where data is isolated in different systems, making it difficult to combine and analyze effectively. Ensuring data accuracy is another challenge. It is essential to keep data clean, consistent, and up-to-date in order to make reliable decisions. Additionally, the sheer volume of data can be overwhelming without the right tools to manage and analyze it efficiently. In conclusion, understanding the different types of marketing data, recognizing the importance of integrating these data types, and being aware of the challenges in managing marketing data are all essential components of a successful marketing strategy. As we continue in our course, we'll dive deeper into these concepts, and you will be better equipped to harness the power of marketing data to drive your business forward. Thank you for following this lecture, and I'll see you in the next one. Hello everyone, and welcome to this lesson. In this lesson, we'll proceed by setting up our environment, and we'll be working with Microsoft Excel. To get started, open any browser of your choice and search for Microsoft Excel. You'll be directed to Microsoft's website, where you can view their various tools and services. If you go to the Plans and Pricing section, you'll find the full Microsoft 365 plan, which offers personal and family options with various pricing. This includes access to all other Microsoft tools. However, you can also use Microsoft Excel for free by signing up for the free version. You'll see the available options for this free Excel version. Once you've accessed Excel, open the Microsoft Excel app. When the app is open, you can start a new workbook. A workbook is essentially a file that can contain multiple worksheets. For example, Sheet 1 is the default sheet, but you can add as many sheets as you like to store different types of related data. For example, you can rename a sheet to something like CRM data or any other name. You can also style the sheet by changing the color of the tab to distinguish it from the other tabs. Additionally, you can hide a sheet if you're working in a team to make some sheets abstract for other members. To manage hidden sheets, you can here click to unhide any sheets that are hidden. You can also delete a sheet if needed. Now let's look at the tabs in Excel. Each tab contains different groups, and these groups are not limited to the options shown here. There is also a dialog launcher, which gives you access to more specific options in each group. This part of the interface is called the ribbon, and it's where all your tools and commands are located. In future lessons, we'll explore these tools in greater detail. Next, let's talk about the Quick Access toolbar. This toolbar gives you easy access to frequently used tools, such as undo and redo. You can customize the toolbar by adding tools you use often, so you don't have to search for them each time. Now, let's discuss cells. Excel works with a grid system of columns, vertical, and rows, horizontal. For example, cell A1 refers to column A and row 1. If I click on another cell, say G5, it refers to column G and row 5. The grid in Excel is extensive and can extend far beyond what you see on the screen. You can zoom in or out to adjust your view. Let's set the zoom level back to 100% for now. You'll also notice the formula bar, which we will explore later in the course. This bar allows you to enter and view formulas in Excel. Each cell in Excel can hold data. For instance, if you type hello in cell A1, the value will be displayed both in the cell and in the formula bar. Similarly, if you enter world in cell A2, the value will be reflected in the formula bar. That's it for setting up Microsoft Excel. In the upcoming lessons, we will dive deeper into how to use these tools and options effectively. Thank you for following this lesson, and I look forward to seeing you in the next one. Hello everyone, and welcome to this lesson. Today we're continuing our course, and specifically we'll be discussing formatting. But before we dive into that, let's look at an example of campaign data. In this lesson, we're working with campaign data to see how we can format it. A marketing campaign refers to different promotional efforts you might run to reach your customers, such as a product launch, online advertisement, or a social media promotion. We'll start by creating a table for the campaign data. First, I'll insert the header. We have the following columns. First, we have the campaign name. By double-clicking here, it adjusts the width of the cell, making sure that the content fits well, or we can wrap up the data. This makes the data to expand across various lines in order to make it visible in the cell. That is not much necessary here. We then have the start date, end date, the budget, the revenue, and also the click-through rate, CTR. As we proceed, I will refer to this as CTR. The click-through rate measures the effectiveness of an ad in getting people to click on it. It is calculated using the number of total clicks divided by the total impressions, all times 100. So here, the total impressions is the number of times the ad is being shown to users, and the clicks, the number of times people have clicked on the ad. So this click-through rate is simply the number of clicks the advertisement got with respect to the number of times it had been shown to users. We then have the conversion rate. The conversion rate measures the effectiveness of your campaign in getting users to complete a desired action after clicking on the ad. This action could be purchasing a product, signing up for a newsletter, or another action defined by the campaign. This defines how the campaign user has completed the action you wanted him to partake in. For instance, if you are selling a product, you want that everybody that clicks on the ad should purchase that product. It is measured by the total clicks divided by the total conversions times 100. A high conversion rate indicates that once users click on an ad, they are more likely to complete the desired action, whereas a high CTR means that a significant number of people who saw the ad clicked on it, indicating that the ad is compelling and relevant to the audience, but it doesn't necessarily mean that they converted or they purchased the service. We are going to style these headers differently. So here we have the font, text, and size. Here, by doing this, you can increase the size, for instance. Also, let's make them bold for better visibility. You can also fill the cells with a different background color to distinguish them. This should be okay. By clicking Ctrl+A, we select all of the cells. Then by right-clicking and selecting this option, we can adjust the row height. I'll set it to something like 25. Let's adjust these cells' width and center the content horizontally and vertically. Once the headers are formatted, let's enter some data. Practically, the data set is large, but here I am giving an example, so I will make it brief. For example, for the campaign name, we could enter Summer Sale, Black Friday, Spring Offer, and Winter Promo. Make sure the data is centered both horizontally and vertically to make it look clean. Now, for the date columns, this starts on the 1st of January 2025. But first, we have to set the date format. For the start and end dates, select the short date format from the number group under the Home tab. This ensures that Excel recognizes these values as dates, which is important for performing date operations later. Once the dates are set, you can drag to fill the rest of the cells with similar date formats. Here, you can see it increments the date by 1 rather than just copying the value into other cells. For the end date, January 5th, 2025 can be okay. Then we set the type to short date. So here, I'll change the dates to make our data look accurate. Let's say the 25th of November to the 29th. That is when the campaign was run. Here, for instance, we have the 1st of April to the 15th of April. For this last one here, we have a 12th, 10th to the 24th of the month. Since we are dealing with winter promo, it should be obviously in the winter period. Next, we have the budget. The budget is in currency, so we set the type to currency. First, let's enter values like 5,000, 10,000. Numbers are always aligned to the right. 3,000, 4,500, 8,000, 15,000, and 6,000. These values should be formatted as currency. So, we'll set this to dollar currency and remove the decimal places since they aren't relevant here. You can see more currencies by clicking on More Accounting Formats here. For instance, I can set this to euros. Let's leave it as dollars. For the conversion and click-through rates, we are dealing with percentages. So we select the type as percentage. For example, we can enter 2.5%, 5%, 1.8%, and 2%. For the conversion rate, we have 3.5%, 6%, 2.2%, and 2.8%. This is an example of what the campaign data can look like. Now let's make it stand out by giving it borders. Here, you can decide to apply borders on the left, right, top, or bottom of the cells. You can also define more, like the color of the border. So we've set the borders, and now we have a well-formatted campaign dataset. Another thing we can do is use conditional formatting. Conditional formatting means making data stand out when certain conditions are met. For example, if I select this range and apply a color scale, you can see it goes from green to red. The lowest value is shown in red and the highest value in green. This allows you to see where the late campaigns were, and you can spot the campaigns with the highest click-through rates. You can also try different options like data bars or set a 3-color scale. This is what it looks like, but for now, let's stick with a 2-color scale. You can customize the color scales to vary from a given value to another. For instance, the lowest can be from 0% to the highest 100%. I prefer it to be based on the range of the values given in the data. Once this is set, you'll see how it ranges from deep red to deep green, with shades of yellow and orange in between. These formatting skills are essential in marketing analytics because they make your data easier to understand and present. They allow you to quickly spot trends, successes, and areas that need improvement. For instance, you can immediately see that the click-through rate and conversion rate for the spring offer campaign are low, which requires immediate attention. That's it for this lecture. We'll continue in the next one. Hello everyone. In the last lecture we discussed data formatting and we saw an example of how it looks. So, in this lesson, we're going to talk about data validation, drop-down lists, and some arithmetic operations. So, Let's get started. First, let me name these sheets for clarity: data formatting and data validation. A common practice is to select all the cells and fill them white, then start filling the values at cell B2. Data validation is a feature in Excel that helps ensure the accuracy and consistency of the data entered in your cells. It allows you to set rules to restrict data to specific types, ranges, or formats, which helps prevent mistakes and make sure that the data you collect is useful for analysis. So here we are going to use a series of data, which is about some products. So we start by entering our data. We're using sales data for this, and we have a column for product name, units sold, unit price, total revenue. Let me wrap this as well. Then we have region and sales representative, and lastly, the sales date. We'll use product names like product A, product B, product C, and product D. We won't need a very large data set. This is enough for this example. Now, let's move on to formatting. First, we add borders. We also format our headers by increasing the size, making them bold, and centering them. We also wrap the text for neatness. Let's enter the units sold: 100, 200, 50, 150. First, we set the type of these cells to currency. Then we enter the unit prices for each product. Product A is 50, product B is 30, product C is 20, and product D is 70. Next, we'll apply data validation for the units sold column. For this, we want to restrict the entry to only values between 0 and 1000. To do this, we select the units sold column, go to data, then data validation. Here you can see it is set to any value, meaning that any value can be entered there. We then set the validation criteria to whole numbers and define the range as 0 to 1000, because the meaning units that can be sold is 0, and let's assume the maximum to be 1000. If I enter a value greater than 1000, like 15,000, Excel will show a warning saying this value doesn't match the data validation rules defined for this cell. I can either retry to enter the input or cancel, and the original value is maintained. Next, we set data validation for the unit price. We select the column, choose decimal, and set the range between 1 and 100. Now, if I try to enter something outside this range, like 500, it will trigger an error message. So you can either retry or leave the current value. You can also use the Circle Invalid Data tool to highlight invalid entries. For example, if a non-numeric value is entered, like a string, Excel will mark it as invalid. Here, for instance, you can see that the header is circled as it does not conform to the criteria we defined. We can just clear and continue. It doesn't bother because with large data sets, you can't always select all of the cells, so it will be easier to select the column at once. For the total revenue, we will now perform arithmetic operations. Start by using the equal sign. Excel recognizes that you want to perform an operation. In this case, we will use the product operation. Excel offers a variety of functions. If you click on the most recently used tab, you'll find the functions you've recently worked with. If you navigate to all, you'll see a comprehensive list of available functions. There are several categories of functions such as financial, data, time, math, logical, information, engineering, and statistics, among others. However, for this example, we will stick to the most recently used functions. You can type the description of the function you are looking for, and Excel will give you functions that corresponds to what you are looking for. Now, let's select the product function. You can either choose it from the list or simply start typing the function name after entering the equal sign. As you type, Excel will suggest functions. For example, you can select product from the suggestions. In this case, we want to multiply two values, this one and this one, which gives the total revenue for product A. To make the result more readable, we will format it as currency. If you prefer, you can use the column for the calculation. For instance, if you want to calculate the product for the range of cells from C3 to C6, You can close the bracket after selecting the range, and Excel will calculate the product for all the cells in that range. This method works for functions such as sum, addition, or difference, and you can easily apply it to any operation you need. A quicker way to perform calculations is by directly using operators. For example, to multiply, select the cell and use the asterisk operator. This will also work as expected. Similarly, for addition, you can use the plus plus sign, and for subtraction, you can use the minus sign. These operators will function as expected in your formulas. Once you've set up the formula, you can apply it to the other cells by filling them down. Excel automatically adjusts the formula to refer to the corresponding cells. Here, you can see that the value of the cell is the formula, not the amount we see. So when you fill the other cells, it is the formula that is copied and incremented accordingly. For example, for C 3 times, D3, it will adjust to C 4 times, D4 for the next row. Now let's move on to the regions. We'll use a drop-down list for data validation. This ensures that the user can only select from predefined options. Choose List from the data validation options and input the region names: North, South, East, and West. Let me extend this to the other cells, or you chose the column before setting it. Here, for example, I can choose North, East, South, West. After applying this, the user can simply click the cell and select a region from the drop-down list, ensuring consistent formatting and spelling across the spreadsheet. This also eases the work of the users when entering data. You can also create a similar drop-down list for sales representatives. However, in this case, I will manually input the names John Smith, Alice Johnson, Bob White, and Claire Brown. If desired, you can set up a drop-down list for sales representatives as well. Moving on to sales date, it's important to set the data type before entering information. This helps Excel recognize the type of data being entered, which is crucial for performing specific functions. For example, if I enter 1st January 2025 and press enter, Excel will recognize it as a date. Setting the type beforehand makes it easier to fill in related data, such as months, which will increment the months or fill in the years. So here I have the day, month, and the year. You can also apply date restrictions for a specific range. For example, restrict data entry to dates within 2025, 01/1/2025 to 31/12/2025. If a user tries to enter a date outside of this range, as in 2026 for example, Excel will prevent it. Once you've set up the data types and applied any necessary restrictions, you can proceed to formatting. Formatting is an important step to ensure consistency across the spreadsheet. Data validation plays a crucial role in ensuring accuracy. By limiting the type of data that can be entered, it helps reduce errors such as negative numbers or incorrectly formatted dates. It also ensures consistency across the entire spreadsheet. For example, the drop-down list for regions helps avoid spelling errors and ensures uniformity. Limiting data entry reduces human error, especially when multiple users are involved. It also saves time, as users can simply select values from a list rather than typing them manually, which eliminates the need for time-consuming corrections or data cleaning. As we continue working with marketing analytics in Excel, you'll see how important data validation is in maintaining the integrity of your data. That concludes this lecture. See you in the next one. Hello everyone, and welcome to this lecture. In the previous lecture, we discussed about data validation, and we also saw how to add drop-down lists and perform some basic arithmetic operations and the data. So, in this lecture, we are going to proceed and see how to import data from various sources. So the sources we are going to focus on, we have different file types, such as the CSV, which is the comma-separated values. It is a plain text file format that stores tabular data where each row corresponds to a record. So let me show you what it looks like. This is in CSV format. It is written and represented this way, where each data value is separated by a comma. So this corresponds to a record, this to another record, and this is another record. So when imported into Excel, this is going to be a table. This format is very useful because when transferring data between systems, it is being consistent. For instance, when importing data from an Excel from one operating system to another, it can lead to inconsistency, whereas within this format, it remains very consistent. And also, it is storage efficient, that is, it is suitable for storing large data sets without consuming much storage. Also, many data sets, databases, analysis tools, and APIs export data in CSV format due to its simplicity and software compatibility. So now that we have seen this, let's see how we can import it to our Excel. Most often, the type of data you're going to find online is in CSV format. So to import it, you simply come to Excel, and under data, we have this get data here. So here, for example, you can see from text or CSV format. Also from file, you can export from text or CSV format. So inside here, we have these CSV files. If you noticed, here we have 3 files, but in here we only see 2 files because this is stored in CSV format. The other one is an Excel file. You can see that the file type is CSV. I'm going to select this first one, and here now you can see it is well structured. This is how it is being stored when we are importing it in Excel. This is what it looks like as a CSV file. So Excel reads it and transforms it into a table. As you can see, the limiter is comma separated comma. Okay, so this is already clean. You can just load it. You don't need to transform it anymore. Alright, so here this is a table, and you can easily change the style of this table here. So having a data formatted as a table offers a lot of advantages, which we are going to see in the next lectures. For now, we are just going to focus on the importation of these files. So here is our data, and everything looks good and organized. Now let's see how you can import data into an Excel file from another Excel file. Let's simply come here from Excel workbook, and here we have this sales data here. This is going to open the workbook and structure it, and in that workbook there's only one worksheet. Let me show you. Okay, so it is being used. Now we can't open it, and here is the data we have under the sales data workbook. So you can go through these properties and bring in some modifications. Here we have all the data types being defined, and you can simply go ahead and load it. Alright, here is the sales data. You can see this is the original sheet, and this is the data that we loaded. If I close this, and this, you can see this is our sales data that has been imported successfully. So you can import from various sources, from the web, for instance, directly by pasting the link here, or as well from databases or various other sources or online services, as you can see here, but the concept and the logic remains the same. For instance, when importing from a server, you simply specify the address or the name of that server which you have access to, and credentials will be asked, and then you type in the name of the database, and that is done, and the procedure will be the same. Here you can see how effective it is to import the data from various other sources across the world. So here we are using very short data. That is just for demonstration, but when working in practice, the data is very large. That is why in here I have a CSV file here. You can see it when I open it. This is what the CSV file looks like. It will be really complicated to copy this data into an Excel sheet. So that's why when working with Excel, you simply come here and import it, select from CSV, chose Superstore data, and now you can see it is very well structured. You simply load this data. Alright, so we have our large data set. You can see it is really well structured into a table. This shows how effective importing data into Excel is and how useful it is. So that's all for this lecture, and in upcoming lectures, we are going to see how to process and clean this data. See you in the next lecture. Hello everyone, and welcome to this lesson on structuring data consistently for marketing analyses. This is one of the foundational steps in ensuring your marketing data is accurate, usable, and ready for analysis. Inconsistent or poorly structured data often leads to misinterpretations, errors, and unreliable insights, which can ultimately derail your marketing strategy. So, what is data structuring? Data structuring is the process of organizing raw and structured data into a clean, standardized format. It ensures that all entries follow the same conventions, making it easier to analyze and derive actionable insights. For example, in a data set containing marketing transactions, you may encounter inconsistencies in how dates are recorded. For instance, one row may use a short date format, while another uses a long date format or even a custom date format entered by the user. These inconsistencies can disrupt your ability to sort, filter, and aggregate data. Structuring aims to solve these issues and create a uniform format across all records. Structuring data has several important benefits. When data is well structured, it enables accurate calculations, aggregations, and reporting, which are crucial for effective analysis. It also improves the ease of visualization, allowing you to create meaningful charts and dashboards that are intuitive and impactful. Structured data saves time by reducing the need for repetitive cleaning during analysis. It fosters better collaboration among teams by ensuring everyone works with a consistent dataset. Most importantly, it helps prevent errors caused by duplicate records, missing values, or inconsistent formats, which can skew your conclusions and lead to flawed decisions. Common issues with raw data can make structuring a challenging task. For instance, you might encounter inconsistent formats, such as mixed cases for text entries. One row may have all text written in lowercase, another with only the first letter capitalized, and the rest in uppercase. There may also be different date formats, which can cause further inconsistency. You might find duplicate records that distort metrics like revenue and customer count. Missing values are another concern, as gaps in key fields can disrupt calculations or cause errors in reports. Additionally, misaligned data, where columns don't match their intended structure, can complicate analysis. Irregular characters, such as unwanted symbols, extra spaces, or inconsistent delimiters in numerical or text fields, can lead to incorrect grouping or misinterpretations. To address these challenges, there are specific methods and tools you can use. Removing duplicates is a critical first step. Excel's built-in Remove Duplicates feature makes it easy to identify and eliminate redundant rows. This is especially important for ensuring that metrics like revenue or customer count reflect reality. Cleaning text fields is another essential task. Using Excel functions like trim, you can remove unwanted spaces. Functions like proper, upper, or lower help standardize capitalization. For example, you can convert text to a consistent format across a range of data, creating a more professional and consistent dataset. Standardizing dates is one of the most crucial tasks in structuring data, given the variety of formats that can appear in a dataset. Tools like text, date value, and find and replace help you convert inconsistent date entries into a uniform format. For instance, you can structure dates as day, month, and year, ensuring that all records follow the same convention. Using find and replace allows you to fix repeated errors in text fields. For example, you can replace January with 01 in a column of dates to make them uniform and ready for conversion into a valid date format. Validating data as it is entered is a proactive way to maintain consistency. Excel's data validation feature allows you to set rules such as restricting date inputs to the year 2025, ensuring that your dataset is consistent from the start. This reduces the need for extensive cleaning later. Lastly, formatting numbers is vital for fields like revenue. Removing symbols such as the $sign or commas and formatting these values as numbers makes it easier to perform calculations like totals or averages. By applying these structuring techniques, you create a clean, organized dataset that is accurate, efficient, and ready for analysis. This process not only saves time and effort, but also ensures that your insights are reliable and actionable, giving you a solid foundation for any marketing analysis. In the next lecture, we are going to work with unstructured data and structure it using the methods discussed here. Thank you for following this lesson. I hope you now have a clearer understanding of the importance and methods of structuring data for marketing analytics. See you in the next lecture, where we will apply the theory learned here. Hello everyone, and welcome to this lesson. In this lesson, we are going to continue our discussion on structuring data. We have already seen it theoretically, and now we will move into the practical part. The dataset we imported previously is quite large and is already somewhat structured. It has been arranged into a table, and as you can see, even when scrolling down, the headers remain visible. We have this dataset here, and we'll be working with it. First, enable editing. This dataset is just a sample to help you easily grasp the concept. You can reposition the dataset to center it, but for now, we'll work with it as it is. Let's start by adjusting the width of the columns accordingly. Once that's done, we can add borders. Adding borders helps distinguish the data when it's not in table format. Let's add a style to the headers to distinguish it from the rest of the data. Something like this, simple, should be okay. The first issue you'll notice with the imported data is that some numbers are formatted as text. To fix this, select the relevant cells and convert them to numbers. That's done. Next, look at the names column. The names are not well organized. For example, some are written in lowercase, others with inconsistent capitalization. This is lowercase, lowercase, and this is one uppercase. To fix this, insert a new column and enter a formula. We'll use the equals proper formula, which converts text to proper case by capitalizing the first letter of each word and setting the rest to lowercase. Select the text, apply the formula, and close the bracket. When I drag this, it applies the formula to the remaining names. The names are now formatted properly. The first letter of each name is capitalized, while the remaining letters are in lower case. We also upper, which is used to capitalize all letters, as you can see. And we also have lower, which makes changes all of the letters to lower case. Let's change this back to proper. You can then copy the results and paste them as values to avoid copying the formula. Once pasted, delete this column. Repeat this process for all relevant columns to ensure consistency. We are going to the same thing for the regions. We write the formula and copy it to these remaining cells. Then copy and paste by value. We can now delete this one. We do the same for the product column, insert. Then we copy the formula, copy and paste by value, and we delete. You may also encounter data entries that include inconsistent formats, such as $signs in numeric columns. To fix this, first, convert the data to numbers. However, the $signs prevent direct conversion. To resolve this, use the Find and Replace feature. Here you have the Find feature, which help you to search values in your worksheet, and we have the Find and Replace feature, which find and replaces a given value by another. You can access it here or you can press Ctrl plus H to open the dialog box. So we are going to find and replace all dollar signs with empty spaces. When I click on replace all, you can see that it removes the dollar sign. We then convert this column to numbers. We then format it to currency and remove unnecessary decimal places. Now, let's get to the date column. At this point, you might encounter some complexities due to variations in how data was originally entered. Each user may have entered data differently, which requires extra vigilance to ensure uniformity. Structuring this data will be a bit lengthy and complicated, so we will stop here for now. In the next lecture, we will proceed step by step to continue structuring this dataset. That's it for this lecture. We'll continue in the next session. Hello guys, and welcome to this lesson. In this lesson, we are going to proceed with our data structuring process. We are continuing with the dates from where we left off. The easiest way to handle dates is by grouping them together. When you select the concerned date, you can sort it. We can have them sorted alphabetically. We chose expand the whole selection so that it will sort the entire data set and not just the date column. Now you can see similar data grouped together, making the task easier. You can reverse the sorting if you want the list in a specific order. We are going to add a column now, and actually we will add several columns. Here is the first one. What we want to do is maintain a consistent format across all the data. To start, you can link the data in the new column directly to the existing one as it is already well formatted. After that, we will apply a formula. For instance, let's remove all occurrences of first in the text. Everywhere first appears, we are going to use the substitute function to replace it with an empty string. This function replaces existing text with new text in a string. So, wherever st appears in the data, it will be replaced with nothing. This works like the replace function we saw previously, but is sometimes more accurate. Next, we modify the data further by removing commas. When you hit enter, the commas are removed. We continue this process until all unnecessary characters are removed. This completes the first step. We will now insert another column and proceed to change the data into numbers. For example, if the month is written as February or March, we will replace them with 02 and 03 respectively to represent the second and third months. This one is already okay. For this one, we are going to copy this formula here. Oops. Okay, we change this to G2. Then we change Feb to 2 and we copy the formula to the other cells. And we do the same for these ones here by replacing March with 3. This process can be lengthy for large data sets. We still need another column to ensure everything follows the same format. These are helper columns, which we will remove later. We copy our previous formula and make adjustments to apply it to the new data. Here, we remove this slash to that ensures all characters are properly concatenated. You will understand why I did this later. Next, we are going to eliminate extra space characters with empty space. Here, this is not an empty space because there is space character. You can now see how this aligns the day, month, and year consistently. We have 2, 2, and 4 digits, whereas here we have 1, 2, and 4 digits. Here it is 2, 1, and 2. This is where things get a bit more complex. We want to concatenate the data correctly. For example, we add a 0 in front of single-digit numbers. So we first copy this one as it is, then we add a leading 0 to single-digit months or days for uniformity. So here we are going to add a 0 in front of this date by using the AND operator. Here, this is even more tricky as we need to add a 0 here and include 2000 to convert years like 25 to 2025. Using the left function, we extract the first 2 characters of a string. Similarly, the MID function helps extract characters from the middle of a string, and the right function extracts characters from the end. For instance, the left function takes the first 2 digits for the day. Then we use the emid function to extract the month from the middle, but first we concatenate a 0 before that. Then we extract the middle text from position 3. You can see it here, 1, 2, 3. We copy just one value and we keep on concatenating. Then the right function grabs the year from the end. We start counting from the end of the text and we extract the last 2 values. Actually, we have to remove this bracket and add 2000 to this value. Now we have to format IY as date. For that, we are going to use the date formula. As argument, we are going to use the last 4 digits of this text as the year, then following 2 digits as the month, and the first 2 as day. So here we start with write and use the last 4 digits. Then we use mid and use the 2 digits found at position 3. Finally, we use the left function to pass the first 2 values as arguments for the day. You can see it has converted the text to a valid date format. For that, you have to change this type to date format. This is still the same as the first format, but this one is different because the month comes before the day. So we are going to swap these values. This is not accurate. And this is because here we had to change this to 3 and not 2. You can see it changes the date consistently. Once we apply these formulas, the dates are formatted consistently as day-month-year. We copy the results, paste them as values, and delete the helper columns. This ensures the dataset is clean and ready for further processing. At this point, all dates follow the same format and are recognized as valid dates in Excel. This makes it easy to perform operations on them. For the payment method, we are simply going to use the proper function to rewrite it. We then copy these and paste at the original column. In case of exceptions like PayPal, we can use the find and replace feature to rewrite it. The email column is well structured, unlike the contact number column. We'll use substitute to clean this column. For example, we remove unwanted characters like brackets, spaces, or hyphens. Using the substitute function, we replace the brackets with an empty string. One thing is that we can also nest the substitute function like this, so we are also going to substitute the closing bracket with an empty string as well. We add another to remove the extra spaces and another one to remove the hyphens. This step ensures the data is free from irregularities. Once the data is clean, we can format it uniformly using the text function. This function helps format numbers in a consistent manner, such as adding spaces or hyphens where needed. For example, we format contact numbers to follow a standard pattern with groups of digits separated by spaces or hyphens, so this is the standard format for the phone number. We repeat this process for the rest of the dataset. After cleaning, we copy the final results, paste them as values, and delete unnecessary columns. This ensures the data is concise, clean, and ready for analysis. We then use the proper function to structure the product category column. At this stage, the dataset is much cleaner and well structured. All transaction IDs, customer names, regions, products, revenues, dates, payment methods, emails, contact numbers, and product category are formatted consistently. The dataset is now uniform and easy to process. If you want to perform further operations, such as sorting by customer name, you can easily do so. You can select this column and sort it as desired. This structured dataset enables seamless processing and analysis, saving time and effort. That concludes this lesson. Thank you for following along. The next step is to practice and understand how these methods work in detail. See you in the next session. Hello everyone and welcome to this lesson. In this lesson, we are going to see how to repeat these very steps here in just a few clicks and make the process very, very easy. I just noticed that there are spaces at the beginning of some cells in this column. One way to fix this is by using the trim function, which removes extra spaces. I am going to apply it to the entire column. When I do this, you can see that the spaces are removed. For instance, this cell had a space, and now it doesn't. It works perfectly. I'll just copy the results and paste them back into the original column. With that done, I will clear the helper column. Now, let's focus on how to structure data. I have saved this structured data set. In case you don't know how to save your file, you just go to Save As for the first time, choose the file path and directory where you want to save it on your machine, and then click Save. I saved this as structured data and chose the Excel workbook type. Now, every time you update the file, you can simply click Save or press Ctrl S to save the changes. This ensures that your structured data remains intact. If we compare this structured data to our unstructured data, you can already see the difference. The structured data is more organized and visually appealing. Fixing and sorting this structured data is straightforward, but the real challenge lies in managing the date values. To simplify this, you can use AI tools, for instance Copilot, which is a Microsoft AI tool, or any other AI tool you are comfortable with, such as ChatGPT, for instance. Simply ask the tool to structure specific values. For example, you can specify how you want the date values formatted, such as dd/mm/YYY, or any other format you prefer. If you have an account, you can sign in or create one. Once logged in, paste the values into the tool and it will process them for you. After processing, you can copy the structured values back to your Excel sheet and paste them. Sometimes you may notice minor alignment issues, so make sure you ask the AI to arrange the data properly before pasting it. Now you simply paste these values in your worksheet. The tool can perform these tasks much faster than manual methods. What might take hours can now be completed in minutes. If you're working with a very large data set, you can ask the AI to save the results as a CSV or Excel file. This saves you the trouble of manually copying and pasting large amounts of data. Similarly, you can use the AI tool to structure other types of data, such as numbers. We copy this and ask the AI to format it for us in the format 3 digits, a hyphen, and 4 digits. The tool can structure the numbers accordingly, and you just need to copy the results and paste them back into your Excel sheet. Voila, that's it. You can use AI tools to fix various types of data. While AI tools are very helpful, it's important to understand the logic and methods behind the process. This way, you can do it yourself when needed or make corrections directly in Excel. That's it for this lecture. We are going to end here. Thanks a lot for watching, and I'll see you in the next lesson. Hello everyone, and welcome to this lesson. In this lesson, we are going to proceed and see what comes next after you have imported and structured your data. In the previous lesson, we worked on structuring the data. However, there is one more step that I didn't mention, and it's very important. For instance, you can see here that this data contains duplicates. These two rows are exactly the same. You can see the contact number, and every piece of information is identical. Having duplicates in your dataset unnecessarily increases the size of your database and can cause difficulties during analysis. For example, if you sum the revenue, duplicate entries will inflate the figures because the same data will be counted twice. This will lead to misleading results. Once you have your data ready, you can use Excel's built-in tools to remove duplicates. To do this, select the entire range of data. Then go to the Data tab and you'll find the Remove Duplicates option. This feature allows you to choose specific columns to check for duplicate information. For instance, you might want to check only the transaction ID and customer ID. If both are the same, the row is marked as a duplicate and can be removed. However, if a customer makes multiple purchases, it's important to ensure that only transaction IDs are checked for duplicates, as no two transactions should have the same ID. Make sure to check the My Data Has Headers option if your dataset includes headers. Once you click OK, Excel will process the data and display a summary. For example, it might say, 3 duplicate values were found and removed. 10 unique values remain. Now, your dataset will be clean, with duplicate entries successfully removed. After completing this step, save your work. You can do this quickly by pressing Ctrl+S. Once saved, you can close the file and open another one to continue working. Now, let's move on to a new dataset found in the Course Files folder. These datasets includes Campaign dataset and the Campaign main dataset. The Campaign dataset has fields such as Campaign ID, Engagement Score, Conversion Rate, and Revenue. The Engagement Score is a qualitative measure of how well the campaign performed, categorized as high, medium, or low. There's also data on conversion rates, which represent the percentage of users who completed a desired action after interacting with an ad, such as purchasing an item or subscribing. The dataset also includes revenue generated from the campaigns. In addition, we have another Excel sheet that contains campaign IDs along with details such as the platform on which the ads were run, the amount spent on ads, impressions, the total number of times the ad was shown to users, clicks, the total number of clicks on the ad, and the click-through rate, CTR. As we discussed in a previous lesson, the click-through rate is calculated as the number of clicks divided by the number of impressions multiplied by 100. Let's add this formula to our dataset and convert the results into percentages. This will give us the CTR for each campaign. Lastly, we have conversion data representing the number of successful transactions resulting from the clicks. You can see both sheets have campaign IDs, though they give different information. This ID is something they have in common. You might want to look for a value in this sheet to import into this other sheet here. For that, we'll use the VLOOKUP function to link the two datasets. Often, data from different sources is processed separately and later needs to be combined. For example, we have campaign IDs in one sheet and want to pull the engagement score from another sheet into this dataset. VLOOKUP helps us achieve this. To begin, we'll add a column for the engagement score in our main dataset. Using the VLOOKUP function, we can match campaign IDs from this dataset with those in the other sheet and retrieve the corresponding engagement scores. The VLOOKUP function searches for a value in the leftmost column of a table and returns a value in the same row in ascending order. In this case, the lookup value will be the campaign ID, as it's the common reference between the two datasets. So, we select this ID as it is the same ID we expect to find in the other sheet. Next, we define the table array where the function will search for the value. You can see the range of the selected data in here. This array can be a table in the same sheet, another sheet, or even another file. Then we specify the column index number of the value we want to return. Since the engagement score is in the second column, we enter 2 as the column index. Finally, we choose the range lookup type. It can be true or false. For an exact match, we select false. If the function doesn't find a match for a given campaign ID, it will return an NA error, indicating that the value is not available. If we copy this formula to the other cells, you can see that we have values. If we copy this formula to the other cells, you can see that we have values. For example, the campaign IDs 366 and 536 are present in both datasets. The VLOOKUP function will successfully retrieve their engagement scores. Here we have high and medium, and that is the same values we have in this other sheet, high and medium. However, if an ID is not found, it will display NA. Handling missing or unavailable values will be discussed in a subsequent lecture. For now, it's important to understand how to use VLOOKUP to import specific data from one dataset into another. See you in the next lecture. Hello everyone and welcome to this lesson. In this lesson, we are going to talk about the index match method to look up a value. This is a combination of the index and match functions. Let's start with the index function, which you can see here. The index function returns the element located at a specific position in a given array. For example, let's select this array. Now, we define the row number. If we want to retrieve the value, in row 6, column 2, we input 6 as the row number and 2 as the column number. When we close the bracket, you can see it returns Instagram, which is the value at that specific position. This is how the index function works. Next, we have the match function, which returns the position of a specified value within a lookup array. Let's say we are looking for a particular value. Here, we define the lookup value and the lookup array. The match function will return the position of the lookup value within the specified array. For instance, if we search for an ID in the campaign ID column, it will return the row number where that ID is found. After specifying the array, we define the match type. The match type can be one of three options. 1 less than finds the largest value that is less than or equal to the lookup value. The array must be sorted in ascending order. We also have -1 greater than finds the smallest value that is greater than or equal to the lookup value. The array must be sorted in descending order. Then we have the 0 exact match finds the exact value equal to the lookup value. The array can be sorted in any order. If the value is not found, the function returns an error indicating that the value is not available. For example, if we copy the formula to the other cells, we might see that this ID value is located in row 2 and this one in row 6. You can verify this by checking the rows. Row 2 contains one match and row 6 contains ID 536. When you combine the index and match functions, you can achieve powerful results. Let's clear the previous example and work on a new one. Suppose we want to import the conversion rate, which is given as a percentage. The header for the conversion rate is formatted exactly as the others. To achieve this, we will use the index function to define the area of search, which will be this sheet. Next, we define the row number using the match function. For the match function, we specify the lookup value, in this case the campaign ID, and the lookup array, the campaign ID column. We set the match type to 0 for an exact match and then close the match function. Now, we use the index function to return the value from the correct column. For the conversion rate, the value is located in the third column of the source data. If the ID is not found, the result will be an error. However, if the ID is present, it will return the correct value. For example, for the campaign ID CMP366, it returns 8.13%, and for CMP633, it returns 12.43%. These values match the source data. The process works the same way, regardless of whether you reference the lookup value directly or input it manually. For instance, if you type CMP366 directly as the lookup value instead of referencing a cell, it will still return the same result. Both methods, using a reference or directly typing the value, work interchangeably. That's it for this lecture. Thanks a lot for watching. Hello guys, and welcome to this lesson. In this lesson, we are going to discuss logical and conditional functions in Excel. These functions are essential for creating dynamic spreadsheets based on the conditions you define. Let's begin by understanding why these functions are important. Imagine you are working on a marketing analysis spreadsheet and you want to classify campaigns based on their performance metrics, such as the click-through rate or conversion rate. Logical functions allow you to set rules to evaluate these metrics and return appropriate labels like good, average, or poor. For instance, let's add a header for performance status. One thing you can do is select these data and add borders. For the performance status, we are going to use the if function to check whether the click-through rate is greater than a certain value. Based on this, we will label the campaign as successful or indicate that it needs improvement. Using the if function is simple. It has a logical test, a value if the test is true, and a value if the test is false. For example, we want to check if the click-through rate in this cell is greater than 5%. If it is greater than 5%, we can label it successful, and if it is less than 5%, we can label it needs improvement. Applying this to this cell where the value is less than 5% will return needs improvement. You can copy this formula to other cells and it will automatically check the corresponding values, adjusting the references accordingly. This way you can identify which campaigns need improvement. For example, the campaigns on YouTube or TikTok might need improvement if their performance metrics fall short. From there, decisions can be made on how to optimize these campaigns. You can also use the and function to create more specific conditions. For instance, let's create a performance category. The and function returns true only if all specified conditions are true. We check if the click-through rate is greater than 5% and the conversions are greater than 150. In this case, it will return false. If you combine this with the if function, you can write a formula that labels campaigns as high-performing or average based on the criteria. If both conditions are true, we can label it as high-performing, else we label it average. Here you can see the highly performing campaigns and the average performing campaigns. Similarly, we have the OR function, which is slightly different. For example, let's create an attention status column to identify campaigns needing attention. For example, let's create an attention status column to identify campaigns needing attention. The OR function returns false only if all conditions are false, otherwise it will return true if at least one condition is true. If the click-through rate is less than 5% or the conversions are less than 150, we can label it as attention needed, otherwise it will be labeled as on track. This helps notify you when certain campaigns require immediate attention. This here is greater than 150 and this less than 5%. So, it will return attention needed. This notifies you where your attention is needed and where the campaigns are doing well. To further enhance your workflow, you can use conditional formatting to highlight specific values. For instance, you can use red to indicate campaigns that need attention, making them visually distinct and easier to identify. Nested ifs are also useful when you have multiple conditions to check. For example, let's create a CTR category where we classify campaigns as excellent if the CTR is greater than 7%, good if it is greater than or equal to 4%, and poor if it is less than 4%. The nested if structure allows you to apply these multiple conditions in one formula. For example, if the CTR is 6%, it will be labeled good, while a CTR of 8% will be labeled excellent. Finally, you can use the iferror function to handle errors in your formulas. For example, if a value is not found or a formula returns an error, the iferror function will display a custom message, such as no value found, instead of showing an error. This makes your spreadsheet cleaner and easier to interpret. You can as well do the same for this other column here. That's it for this lecture. Thanks a lot for watching. We are going to proceed with more advanced topics in the next session. See you soon. Hello everyone, and welcome to this lesson. In this lesson, we are going to discuss data aggregation, which involves summarizing and analyzing data. For this, we will use functions such as sumif, countif, and averageif in Excel. These functions allow you to summarize and analyze data based on specific conditions, making it easier to extract meaningful insights. Whether you are working with sales reports, campaign performance data, or customer feedback, these tools will help you efficiently process and analyze your dataset. Let's take a look at how this works. I've cleared up the previous functions because they were making the sheet too long. We will start with something simple, the sumif function. The sumif function sums up a range of values based on a specific condition. For instance, let's calculate the total ad spend for YouTube campaigns. Let's write the heading Total Ad Spend for YouTube campaigns. After setting up the area, we can wrap it up and make it bold. Now, we will enter the sumif formula. The formula starts by defining the range to be evaluated. In this case, the range is the column where the campaign types are listed. The criteria will be YouTube. If a cell in this range matches YouTube, we will sum the corresponding values in the ad spend column. When we apply the formula, the result is $10,925. If you verify the calculation manually, you'll see that this is the total ad spend for YouTube campaigns. To make the result more presentable, we can format it as currency. Now, the total ad spend for YouTube is displayed in dollars. Next, we have the countif function, which counts the number of entries that meet a specific condition. For example, we can count the number of campaigns with a click-through rate, CTR, greater than 5%. Let's label this number of campaigns with CTR greater than 5%. Using the countif formula, the range will be the CTR column and the criteria will be greater than 5. When you apply the formula, it shows that there are 7 campaigns with a CTR greater than 5%. This function helps summarize the data and makes analysis quicker and easier. Lastly, we have the averageif function, which calculates the average of a range of values that meet a specific condition. For instance, let's calculate the average click-through rate for TikTok campaigns. Label it average CTR for TikTok campaigns. The formula uses the CTR column as the range and TikTok as the criteria. If a cell contains TikTok, the corresponding CTR values are averaged. When you apply the formula, it calculates the average CTR for TikTok campaigns. For example, if the CTRs are 17% and 2.5%, the arithmetic mean would result in the calculated average. That's it for using these aggregation functions. You can see how important they are in summarizing data, minimizing workload, and making data analysis more efficient. We'll end this lecture here and explore more about these functions in subsequent lessons. Hello everyone, and welcome to this lesson on key marketing metrics. In this lesson, we will learn how to calculate and interpret essential performance indicators such as the click-through rate, CTR, the conversion rate, the ROI, return on investment, the CPA, cost per acquisition, and the CLV, customer lifetime value. These metrics are foundational to understanding the effectiveness of your marketing campaigns and making data-driven decisions. Let's start with the one you've seen the most so far, the CTR. As you already know, the CTR is calculated as the number of clicks divided by the number of impressions. Here, clicks represent the number of times the ad has been clicked on, and impressions are the number of times the ad has been shown to users. Let's format these as currency. To calculate the CTR, we use the formula clicks divided by impressions. After computing, it's best to convert the result into a percentage for better readability. Let's add it here. The CTR measures how effective an advertisement is in encouraging users to click on it. A higher CTR indicates that your ad resonates well with the audience. Now let's look at the conversion rate, which measures the percentage of users who take a desired action after clicking on the ad. This action could be a purchase, signing up, or any other intended outcome. Here we have conversion rate, which is also in percentage. The conversion rate is calculated as the number of conversions divided by the number of clicks. After applying the formula, convert the result to a percentage. For example, this campaign had 510 clicks and 347 users performed the desired action. It indicates a high conversion rate. This reflects the effectiveness of the landing page or offer in converting leads into customers. Next, we have the ROI, which is the return on investment, also expressed as a percentage. ROI measures the profitability of a campaign by comparing the revenue generated to the cost incurred. Here, we have the revenue and the ad spend. The formula is revenue minus ad spend divided by ad spend. Copy the formula to other cells and format the results as percentages. It's normal for the ROI to exceed 100% as it shows the effectiveness of the ad. For instance, if an ad generates $3,000 from a $500 spend, the ROI is 517%. Conversely, a negative ROI indicates a loss, such as generating $3,286 from a $3,536 spend. A higher ROI reflects better profitability. After ROI, we have the CPA, which stands for cost per acquisition. The CPA calculates the average cost of acquiring a single customer through a marketing campaign. The formula is ad spend divided by conversions. For example, if a campaign spends $500 and results in 125 conversions, the CPA is $4.6. This represents the cost of acquiring one customer. Lower CPAs are often associated with higher ROIs and effective campaigns. For instance, a campaign with an ROI of 1,345% may have the lowest CPA, while a campaign with the highest CPA often has a lower ROI. Lastly, we have the customer lifetime value, CLV, which estimates the total revenue a customer is expected to generate over their relationship with your business. The formula is average purchase value times purchase frequency times customer lifespan. For example, if a customer spends $88 per purchase, buys 3 times a year, and remains with the business for 4 years, their CLV would be calculated accordingly. The 155 helps estimate long-term profitability and is a crucial metric for planning marketing strategies. These key marketing metrics are incredibly important. They provide valuable insights into campaign performance and are essential when creating dashboards to visualize data. They help track the ongoing performance of campaigns and support data-driven decision-making. Before we wrap up, let's style the sheet by adding borders to distinguish the data more clearly. Once that's done, press Ctrl+S to save the file. That's it for this lesson. See you in the next lecture. Hello guys, and welcome to this lesson. In this lesson, we are going to discuss macros and VBA in automating regular routines or tasks. Let's say, for instance, every month or every week you have to generate a report or perform basic operations on the same type of data set, whether new or existing, but the operations remain the same. In such cases, you can use macros to automate these tasks. You simply record yourself performing the operations, and then whenever you need to perform those same routine tasks, you play the macro and it executes the operations for you. To demonstrate this, we have a dataset that we are going to work with. First, we need to add the Developer tab to the ribbon to enable macros. To do this, go to File, then Options, and under Customize Ribbon, add the Developer tab. Once you press OK, you'll see the Developer tab appear on the ribbon. In this tab, you'll find the Macro option, where you can record and manage macros. When you click Record Macro, everything you do afterward will be recorded. When you play it on a different dataset, it will replicate the same operations. Let's start by copying this dataset and pasting it into another sheet. Now we have the same data in two places. Next, let's record a macro. For example, let's say every time you have this dataset, you want to highlight revenue values greater than $10,000. Start by clicking Record Macro. Name your macro, for instance, Highlight Revenue. You can use naming conventions such as camel case or any other standard. Store the macro in this workbook. Optionally, you can assign a shortcut key like Ctrl+U and add a description if needed. It is important as it helps others understand what the macro is used for. For instance, we can write highlights revenues greater than $10,000. Press OK and the recording begins. First, let's apply a background fill to the headers. Next, select the revenue column and convert the values to dollars. After that, apply conditional formatting to highlight cells where the revenue is greater than $10,000. Under conditional formatting, choose greater than and set the value to 10,000. You can choose a green highlight to indicate good performance. Once you've done that, stop the macro recording. Macros can use relative references, which means they adjust dynamically to the dataset even if the data starts in a different position on a new sheet. For example, if the dataset starts in a new location, the macro will still perform the operations relative to the data you select. To test the macro, go to Macros, select the recorded macro, and click Run. You'll see that the formatting and operations are applied exactly as recorded. This can save you a lot of time, especially for repetitive tasks. While this example is simple, macros can be used for much more complex operations. For advanced modifications, you can open VBA, Visual Basic for applications. Under the Developer tab, click Visual Basic to open the editor. Here, under Modules, you'll find the code for your macro, typically stored in Module 1. The code contains all the actions you recorded. While VBA coding is beyond the scope of this lesson, you should know that you can edit or add code in the VBA editor to automate more complex tasks that are not possible directly on the Excel sheet. For instance, AI tools can help you generate code that you can insert into the module to further enhance automation. Finally, when saving your file, you must save it as an Excel macro-enabled workbook to ensure that your macros are stored. Go to Save As and select the Excel macro-enabled workbook format. This step is very important because macros will not be saved in a standard Excel workbook format. That's it for this lesson. Macros and VBA are powerful tools for automating repetitive tasks and increasing efficiency. Thank you for watching, and I'll see you in the next lesson. Hello guys, and welcome to this lesson. In this lesson, we are going to discuss dates and some functions that can be run on it, as well as how to sort and filter data effectively. Here we have a simple dataset to work with. The dataset includes a transaction ID, a corresponding customer name, a purchase date, the date an item was purchased, and the amount. First, we'll format the dataset. Let me apply a suitable format, perhaps add a background fill, and select the entire dataset to add borders. You could also fill any blank cells to make the dataset cleaner, but for now, we'll proceed as is. The first thing we'll do is sort the data. although the dates here are already sorted chronologically, January, February, March, April, and May, let's see how to sort the data in reverse order. This process is particularly helpful for large data sets where dates or other fields might be unsorted. To sort, select the column containing the purchase dates. Ensure that you don't apply the sorting rule to the header cell. You can hold Ctrl and click the header to exclude it. Under the Data tab, choose the Sort option. Expand the selection to include all related data. Specify the column to sort, in this case, purchase date, and choose the sort criteria such as cell value. You can also sort by cell color, font color, or conditional formatting icons. For now, we'll use cell value and sort from newest to oldest. Once applied, the data rearranges accordingly, starting from May down to January. When sorting, you'll notice that the entire row adjusts, not just the selected column. For instance, John Smith T4509 might move to a different position in the dataset depending on the new sorting order. Sorting ensures the integrity of the data remains intact. Now, let's explore filtering. Filters are very useful for narrowing down data based on specific criteria. You can apply a filter by adding the filter icon to the dataset. Filters allow you to sort data as well as apply specific conditions. For example, you can filter data to show transactions that occurred on a specific date, before a certain date, after a certain date, or between two dates. This works with the current state of your machine. Here, for instance, if I chose a filter for this year, it will show blank as you can see. If I chose today, for instance, it will show but the transactions corresponding to today's date. Filters can also show data from specific periods, such as today, yesterday, this month, this year, last year, or specific quarters. For instance, let's filter transactions for January and May only. When applying this filter, you can choose whether to include blank cells. If rows contain blank dates, they will be added to the end of the filtered results. After applying the filter, only transactions from January and May will remain visible. Let's clear this filter. Another useful technique is extracting specific parts of a date, such as the year, month, or day. This can be particularly helpful when analyzing large data sets to group transactions by month or identify patterns like transactions occurring on Black Friday. Add headers like year, month, and day to the dataset for this purpose. To extract these components, use the text function. For example, to extract the year from a purchase date, apply the formula equals text C2 YYYY. Drag the formula down to apply it to the entire column. This gives us the year for this transaction. Similarly, to extract the month, use the copy this formula and change this to MM, which will return the full month name like January or May. For the day, we use DDDD, which returns the day of the week, such as Sunday. By applying these formulas, you can analyze transactions by year, month, or day. For instance, you might notice that all transactions occurred on Sundays due to the dataset being generated with a consistent 7-day interval. However, for real-world datasets, these extracted details will vary and provide deeper insights. That's it for this lesson. In the next lecture, we'll explore additional useful date functions to enhance your data analysis capabilities. See you then. Hello guys, and welcome to this lesson. In this lesson, we are going to discuss some important date functions that can be very useful. We will cover the EOMONTH end of month function, the EDATE end date function, and the DATEDIF function. To start, let me format the data to keep it consistent. The EOMONTH function returns the last date of a month. For instance, If you want to return the last date of a specific month, you can type in the start date. The first argument is the start date, and the second argument specifies the number of months to add or subtract. If I enter 0 as the second argument, it will return the last day of the current month. For example, if the date is January 1st, 2023, the function will return January 31st, 2023. Let me format this as a short date for better readability. Now you can see it returns the 31st of January, which is the last date of that month. If I change the second argument to 2, it will calculate the last date 2 months from the start date, giving April 30th, 2023. This function is particularly useful for setting deadlines such as project completion dates or payment deadlines that fall at the end of a month. Dragging the formula down will calculate the last date for subsequent months. The end date function calculates a specific number of months before or after a given start date. For example, if the start date is today and you want to know the date 3 months from now, the formula will return that date. This is often used for calculating warranty expiry dates or subscription renewal dates. If you use a negative number as the second argument, it will calculate a date in the past. For instance, entering 3 will return the date 3 months prior, such as December 1st, 2022. This function is versatile and can handle both forward and backward calculations. Copying the formula to other cells will apply the logic to each respective start date. The date difference function calculates the difference between two dates. You can use this function to find the difference in terms of years, months, or days. For example, let's calculate the difference between two dates in days. The first argument is the start date and the second is the end date. Then you specify whether the difference should be returned in Y, years, M, months, or D, days. For instance, if the difference between two dates is 119 days, the function will return that value. This is useful for calculating overdue payments or determining how long a project has been delayed. You can also use the DATEDIF function to calculate the difference in months. For example, from January to April, it will return 3 months. Similarly, using Y will calculate the difference in years. This can help analyze project durations or customer tenures. For instance, if a customer was acquired on January 1st, 2023, and the current date is sometime in 2024, you can calculate how long you've had that customer. These date functions, EO month, EDATE, and DATEDIF, are incredibly useful in marketing analytics and various other applications. They allow you to calculate durations, deadlines, and timelines effectively, which is essential for data analysis. That's it for this lesson. I hope you find these functions helpful, and we'll explore more in the next lesson. Thanks a lot for watching, and see you soon. Hello everyone, and welcome to this lesson. In this lesson, we are going to talk about moving averages. A moving average smooths out fluctuations in data over a specified time period, helping to reveal trends and patterns. This is particularly useful for analyzing metrics like revenue, impressions, or clicks, which often exhibit short-term variability. Moving averages help in making better decisions by smoothing out these fluctuations over specified time periods. Let's see how to use moving averages effectively. To begin, I'm going to insert a helper column, which I'll call moving average, and adjust it accordingly. We'll calculate the moving average over a period of 3 weeks. We've already discussed the average formula, which calculates the mean of given numbers. Let's say we are analyzing revenue. The dataset is organized by weeks, which is helpful for our calculations. I'll select the range for the first 3 weeks and calculate the average revenue for that period. Afterward, I'll drag the formula down to apply it to the rest of the dataset. This provides the moving average for each subsequent period of 3 weeks. To demonstrate the usefulness of moving averages, let's insert a graph. First, I'll select the data for revenue and dates by holding Control and selecting the relevant columns. Then, under the Insert tab, I'll choose a chart type. We can change this title to Revenue. The initial graph will show revenue over time, but as you can see, the data is quite rough and fluctuates significantly. These short-term fluctuations make it difficult to draw meaningful insights or make decisions. This is where moving averages become incredibly helpful, especially in marketing analysis. Next, I'll add the moving average data to the chart. I'll select the moving average column, label it as moving average, and add it as a new series. You'll now see a second line on the chart that represents the moving average. This line is much smoother compared to the original revenue data, as it averages the fluctuations over a 3-week period. The moving average provides a clearer view of trends over time, making it easier to analyze performance. Here, you can see that it is easier to read the second line than the first one, as the fluctuations are smoother. Over this given period, for instance, the revenue here is more linear and can be more useful in analysis. Moving averages have several advantages. For example, they help reduce short-term fluctuations, allowing marketers to focus on the overall direction of key metrics like revenue, impressions, or conversions. Additionally, they help track campaign performance. By calculating moving averages for metrics like CTR or conversion rates, marketers can monitor whether performance is improving or declining over time. Moving averages are also useful for predicting future trends by analyzing past data patterns. The smoother data helps project future performance with greater accuracy. Another advantage is reducing noise in data. Marketing analysis often involves data that fluctuates due to temporary factors like promotions or external events. Moving averages filter out this noise, providing a clearer picture. For example, moving averages can help compare consistent performance across multiple campaigns. They also allow marketers to optimize budget allocation by identifying high performance periods and improving decision making. A clear understanding of trends supports better decisions, such as whether to continue or discontinue a campaign. That's it for this lesson. Moving averages are incredibly useful, and I'm sure you'll find them helpful in future analyses. We'll end here, and I'll see you in the next lecture. Hello everyone, and welcome to this lesson. In this lesson, we are going to discuss data visualization in marketing. Data visualization is essential as it allows you to represent data graphically, making it easier to read and analyze. Data visualization enables marketers to identify trends and patterns quickly. It helps communicate insights effectively to stakeholders, simplifies decision-making by focusing on key metrics, and allows for data-driven adjustments to campaigns in real time. However, it must be well represented, as poor visualization can lead to false conclusions and incorrect decision-making. We obviously cannot cover all the different types of graphs in this lesson, but we will discuss the most common ones and how to choose and utilize them effectively. This will give you a solid foundation to work with other charts in the future. Let's start with the line chart, which we briefly covered in the previous lesson. The line chart is used to show trends over time. For example, you can use it to display revenue trends over months or track weekly impressions. It emphasizes proportions and changes over time. To create a line chart, select your dataset, go to Insert, and choose a recommended chart. Excel will often suggest a line chart for this type of data, as it is the most effective representation. After creating the chart, you can position it in your Excel sheet. For instance, you can change the chart title to something like Revenue over Time. The X-axis represents dates, while the y-axis represents revenue. You can also add axis titles, such as revenue in dollars for the y-axis and date for the x-axis. But these are already obvious, so we won't need to add axis titles. Adding data labels can show the exact values for each point on the graph, and you can choose their position: above, below, left, or right. Avoid overcomplicating the chart by adding too many elements like error bars or data tables. Remember, the goal is to make the data easy to understand. You can also add a trend line to represent the overall trend, choosing types like linear, exponential, or forecasting. You can also customize the chart's style. There is much of them here. You can simply create yours. You can as well modify the colors to suit your preferences. Here we have many color ranges, including gradients. That's it for the line chart. We have seen how to add the chart, add other lines on the chart, and how to customize the chart. Next, we have the bar chart, which is ideal for comparing categories. For instance, you can compare ad spend and impressions across platforms on which they were run. Select your data, go to Insert, and choose the recommended clustered bar chart. We can change the title here, but let's not waste time on it. The bars will represent ad spend in blue and impressions in red side by side for each platform: Facebook, Instagram, LinkedIn, and Twitter. Just from the visuals, you already have the idea of the relation between the ad spend and the revenue. You can also customize colors to something like this, for example. Another use of bar charts is comparing values side by side, such as ad spend across platforms. This makes it easier to analyze data at a glance. Next, we have the pie chart. Pie charts are used to show proportions. For example, the percentage of total clicks for each campaign. After selecting the data, Insert, you can see a list of recommended charts. You can use the clustered to represent the data, or use a pie chart. So we'll select the pie chart. This will give us the percentage of clicks for each campaign. We can adjust its size and placement as needed. You can change the colors of the segments. For better representation, we can use this one, for instance. Colors aid in representation, for instance using blue for Facebook and red for YouTube. Adding data labels can also make the chart more informative, displaying the percentage or value for each segment. You can reposition them, change the font size and color. Here are the different options we have in modifying these. While pie charts are effective for showing parts of a whole, they are less suitable for detailed comparisons. Use them for high-level overviews. Lastly, let's discuss the scatter plot. You can see Excel suggests a scatter plot already. You can use it from here. We also have the line chart, pie chart, and many other charts. Scatter plots are used to show relationships or correlations. For instance, you can analyze the relationship between ad spend and revenue. Add axis titles such as ad spend in dollars and revenue in dollars. This visualization helps identify patterns or trends, like how revenue increases with higher ad spend. Scatter plots are particularly useful for decision making by highlighting correlations in the data. Before we conclude, let's briefly discuss the importance of color theory in data visualization. Before we conclude, let's briefly discuss the importance of color theory in data visualization. Colors play a crucial role in making charts intuitive and visually appealing. Poor color choices can confuse or mislead your audience, while thoughtful colors enhance understanding. Key principles of color theory include consistency. Use the same color for a category across all charts. Simplicity. Limit the color palette to 5 to 7 colors for categorical data. Contrast. Ensure enough contrast between colors for clarity. Use darker shades for emphasis and lighter shades for background elements. Highlighting. Use bold or contrasting colors to emphasize key insights, such as red for low-performing campaigns. Accessibility. Choose color-blind friendly palettes to ensure inclusivity. Avoid red-green combinations. Opt for blue-orange instead. When choosing a chart, always ask yourself what you're trying to represent. To show trends, use a line chart. To compare categories, use a bar chart. To show proportions, use a pie chart. To show relationships, use a scatter plot. That's it for this lecture. See you in the next one. Hello everyone, and welcome to this lesson. In this lecture, we are going to proceed by exploring some more advanced data visualizations. In the previous lecture, we covered basic visualizations such as the line chart, bar chart, pie chart, and scatter plot. In this lesson, we'll take it a step further and discuss a few advanced visualizations and their applications. These include the combo chart, waterfall chart, and bullet chart, which offer unique ways to analyze and present marketing data. These charts help convey detailed insights in an intuitive and visually engaging manner, enabling marketers to highlight key performance metrics and identify actionable trends. Combo chart. Let's start with the combo chart. To create a combo chart, select your data, go to the Insert tab, and choose the combo chart option. A combo chart combines two or more chart types into a single visualization. It is particularly useful for comparing data with different scales, such as ad spend and revenue. For example, let's adjust the revenue column to display currency. Once we insert the combo chart, you'll notice that the ad spend is represented as a bar chart, blue, while the revenue is shown as a line chart, red. Let me format these as currency. Here's what it shows. On platforms like Facebook, the ad spend was $9,000, generating a revenue of $17,000. Similarly, you can analyze the trends for Instagram and other platforms. You can add data labels for more clarity. The combo chart helps you identify inefficiencies, high spend with low revenue, and cost effectiveness, low spend with high revenue. This chart is ideal for providing a comparative analysis of metrics with different scales. Next, let's talk about the waterfall chart. A waterfall chart breaks down the components of a total value, showing how positive and negative changes contribute to the final figure. Let's insert the chart. Here we have the blue indicating increase, the red indicating decrease, and the green indicating total. For instance, let's start with a revenue of $12,000. If we spend $4,000 on ads, the revenue decreases to $8,000. Adding a $2,000 discount further decreases it to $6,000. However, upselling generates an additional $5,000, bringing the total to $11,000. Finally, another revenue source adds $15,000, bringing the total to $26,000. Waterfall charts are useful for understanding how individual components, like expenses, discounts, and upsells, contribute to the overall revenue. Finally, let's discuss the bullet chart. A bullet chart is a variation of a bar chart that compares performance metrics, such as actual revenue versus target revenue. Let's select the clustered chart with the actual revenue and the expected revenue. For example, let's say our target revenue was $18,751, but the actual revenue was $12,000. The bullet chart allows you to directly compare these values. You can also modify colors or titles to make the chart more informative. The bullet chart is particularly helpful for tracking campaign performance against targets. It highlights campaigns that exceed targets, as well as underperforming ones that may require adjustments. For example, in some cases, the actual revenue may exceed the target, while in others, the performance falls short and needs improvement. You can also experiment with other chart types to visualize this comparison. For instance, use a stacked column chart to show actual versus target revenue. Use a clustered bar chart to present the data horizontally. Use percentage-based charts to display performance as a proportion of the target. Each type offers a different perspective, but the choice depends on your specific use case. In this lesson, we explored advanced visualizations, combo chart, useful for comparing metrics with different scales such as ad spend and revenue. Waterfall chart breaks down totals into contributing factors, providing a detailed view of positive and negative impacts. Bullet chart, ideal for visualizing progress toward targets, such as actual versus target revenue. With this knowledge, you now have a deeper understanding of both basic and advanced charts. You're ready to apply these concepts to analyze and present data effectively. Thank you for joining this lesson, and I'll see you in the next one. Hello everyone, and welcome to this lesson. In this lecture, we are beginning our journey on creating interactive dashboards, which are essential for visualizing data and presenting it to clients, stakeholders, or a wide variety of audiences. Before we dive into dashboard creation, there are some foundational concepts we need to cover, such as pivot tables. In this lesson, we'll focus on pivot tables. We already have our data well sorted and formatted. As always, I prefer working with a small dataset in these examples so you can easily grasp the concepts without confusion. However, the principles and reasoning remain the same for large datasets as well. So, what is a pivot table? A pivot table is an integrated smart table that allows you to easily organize and summarize complex data. To create a pivot table, select your data, go to Insert, and choose Pivot Table. Let me show you how it works. For instance, you can select Recommended Pivot Tables, which will offer predefined layouts to summarize your data, such as grouping regions and calculating the total ad spend or total revenue for each region. Here's an example. If we have 4 regions with ad spend data across various platforms, the pivot table will group the data by region and sum the total ad spend, even if the platforms differ. This makes it easier for teams in specific regions to analyze their performance and progress. Our dataset includes the date advertisements were run, the platforms where ads were run, the amount spent, revenue generated, click-through rate as a percentage, conversions, and the region. Now let's create a pivot table. Select the data range, which is already set, and we'll insert the pivot table in a new worksheet. It's best to work in a new worksheet to keep things clean and organized. Once the pivot table is created, you'll see the pivot table structure where you can select and organize your fields. Let's start by organizing the data by platform. Add platform to the rows section. You'll notice that platforms like Facebook or Instagram appear as row labels. Even if Facebook data appears multiple times in the dataset, the pivot table will summarize it for you. Next, let's add revenue to the values section. The pivot table will calculate the sum of revenue for each platform. For instance, the total revenue for Facebook will be the sum of all Facebook entries in the dataset. If you manually sum up the revenues in the dataset, you will end up with this same amount. Similarly, it calculates the totals for other platforms with a grand total at the bottom. Now, let's add ad spend to the values section as well. Under value field settings, you can choose how the data is summarized, sum, average, count, or even the product of the individual values. For now, we'll stick to the sum. Let's add another field that doesn't exist in the original dataset, return on investment ROI. To do this, go to Fields, Items and Sets and select Calculated Field. Name the field Return on Investment and use the formula ROI equals, open parenthesis, revenue minus ad spend, close parenthesis, divided by ad spend, click OK, and the calculated ROI will appear in the pivot table. By default, it's displayed as a number. To format it as a percentage, go to Value Field Settings, choose Percentage, and set the number of decimal places, for example 2. This ensures accuracy and readability. Now the pivot table provides a clear view of ROI for each platform. For instance, if Facebook has a high ROI, it indicates cost effectiveness, while a low ROI might signal inefficiencies. Here, if I click here for instance, we can have details for the sum of ROI. Let's create another pivot table to calculate the average click-through rate for each region. Insert a new pivot table into the existing worksheet. We set region as the rows field, add CTR to the values section, but instead of summing the values, change the value field settings to calculate the average. This gives us the average CTR for each region, helping us understand regional performance. Let's create another pivot table to analyze revenue and add spend by date. Insert a new pivot table. Here we set the date as the rows field. You'll notice that dates are grouped by month, such as January, February, and so on. Add revenue and add spend to the values section. This pivot table shows the revenue generated and add spend for each month, making it easy to identify trends over time. Pivot tables are invaluable when working with large data sets. Imagine handling thousands of rows and columns manually. It would be overwhelming. Pivot tables allow you to summarize and analyze data quickly and efficiently, saving time and reducing errors. In this lesson, we have explored how to create and organize pivot tables, summarize data by platform, region, and date, add calculated fields like ROI, and use pivot tables to calculate averages and analyze trends. Pivot tables are invaluable when working with large data sets. Imagine handling thousands of rows and columns manually. It would be overwhelming. Pivot tables allow you to summarize and analyze data quickly and efficiently, saving time and reducing errors. In this lesson, we have explored how to create and organize pivot tables, summarize data by platform, region, and date, add calculated fields like ROI, and use pivot tables to calculate averages and analyze trends. Pivot tables form the backbone of interactive dashboards by summarizing complex data into easily digestible formats. In the next lesson, we'll build on this foundation to create dynamic dashboards that effectively present data to various audiences. Thank you for joining this lesson, and see you in the next one. Hello everyone, and welcome to this lesson. Previously we saw pivot tables, and in this lesson we are going to proceed with pivot charts. Pivot charts are simply charts that have been drawn or generated from pivot tables. Before we proceed, let us name these sheets for clarity. Call this one the data set, another for the pivot tables, and another for the pivot charts. From here, we are going to generate a few charts to display on the dashboard. There can be as many pivot charts as needed, depending on who you are presenting the data to. For simplicity, we will focus on a few essential charts that summarize marketing performance and help you understand how they work. The first chart we are going to create is a bar chart for ad spend versus revenue. Select the relevant data and under Insert, choose Pivot Chart. We'll adjust the chart to work only with the sum of revenue and the sum of ad spend, removing any unnecessary fields like the sum of ROI. Place the legend at the bottom for better visibility and hide all buttons as they are not needed for now. Add a chart title, Ad Spend versus Revenue by Platform. This chart is ready, so let's cut it and leave it here for the moment. Next, we'll create a line chart to show trends over time. Using the relevant pivot table, select the data and insert a line chart. The chart might look a bit rough. For smoother results, it's better to use moving averages when working with actual data. For now, we'll leave this as is for demonstration purposes. Position the legend at the bottom and adjust the chart title to Monthly Revenue and Ad Spend Trend. This chart is ready and can be placed next to the first one. Now, let's create a pie chart. For instance, we can visualize conversions per region since our data set includes conversions. Add the conversions field to the pivot table and summarize it by region. Insert a 3D pie chart to represent this data. Add data labels, remove any unnecessary fields from the chart, and adjust the title to Conversions by Region. This chart is now ready and can be placed with the others. To make these charts more interactive, we can use slicers. Slicers allow us to filter data in pivot charts, pivot tables, and even the dataset itself. You can also rename pivot tables to keep track of them. For example, one pivot table might be named Pivot Table 7 and another might be Pivot Table 9. Renaming them can make it easier to manage when connecting slicers. For example, select a pivot table and add slicers for fields like date, platform, and region. These slicers can filter the data dynamically. For instance, selecting January in the date slicer will display data only for January across all connected charts and tables. Let's choose the first 4 months. You can see it affects other slicers as these platforms are not concerned within the chosen time frame. Similarly, selecting a platform like Facebook will adjust the data for that platform alone. Instagram, LinkedIn. With slicers, you can filter data in real time and observe changes across charts and tables. For instance, selecting a specific platform like Facebook will update the corresponding chart and table to show data only for Facebook. This functionality is essential when organizing everything into a dashboard, which we will explore further in upcoming lessons. For now, let's cut them, place them here with the charts. That's it for this lesson. We've created pivot charts and added slicers to filter data interactively. In the next lecture, we'll continue building on these concepts and organize everything into a cohesive dashboard. Thanks a lot for watching, and I'll see you soon. Alright guys, hello and welcome to this lesson. In this lesson, we are going to draw the layout of our dashboard. But before we dive into that, let me talk about something I didn't mention in the previous lesson. When you have slicers, it's essential to link them to the appropriate pivot tables so they can affect the pivot charts. Remember, pivot charts are generated from pivot tables, so anything that affects the pivot tables will also affect the pivot charts. Here, we want this slicer to affect this pivot table, we want the platform slicer to affect this one, and the region slicer to affect this one. For example, for conversions by region, this slicer needs to be linked to the pivot table it was derived from, which is pivot table number 9. You can rename pivot tables to keep track of them, which is also helpful. To link a slicer, go to the slicer settings and choose Report Connections. Link it to the appropriate pivot table. Once that's done, you'll see the slicer affects the chart. For example, selecting 3 months like May, June and July will adjust the chart accordingly. Similarly, link the region slicer to pivot table number 8 and it will affect all connected charts and tables. Now, let's create another pivot chart for the click-through rate CTR. Start by inserting a new pivot table from the dataset into an existing worksheet. For this one, we want the regions in the rows and the average CTR in the values. Once the pivot table is ready, create a pivot chart. Remove unnecessary buttons and format it as needed. Adjust the chart title to average click-through rate by region. Make sure the chart is linked to the corresponding pivot table, which in this case is pivot table number 10. Now this chart is ready and can be added to our collection. Next, we'll move to the dashboard. Let's add the sheet dashboard and position it appropriately. The first step is to decide on the layout and theme for the dashboard. Select a uniform color scheme, such as a bluish tint to maintain consistency. Adjust the overall formatting to match the theme. Now, let's design the structure of the dashboard. Insert shapes to create sections for the slicers, title, graphs, and metrics. For example, place slicers on one side and reserve the rest of the space for graphs and key metrics. Format these sections to align with the dashboard theme. The design is all up to you and your imagination and creativity. Add a title like Marketing Performance Dashboard and include the year, for example 2023. Adjust the title color to match the theme and ensure it stands out. For the title, use a bold, large font size such as 44 and align it both vertically and horizontally. Below the title, add sections for key metrics. For instance, include total ad spend, total revenue, and return on investment, ROI. Divide the space evenly for these metrics. For example, if the total width is 48 units, divide it into 3 sections of approximately 16 each. Format these sections to make the metrics clear and visually appealing. Let's just another one for another metric. Now, we'll place the slicers, maps, and charts in their designated areas. For now, we'll keep the layout simple without finalizing the design. We'll refine it further in the next lesson, when we add more details and interactivity to the dashboard. That's it for this lesson. We've linked slicers, created pivot charts, and laid out the initial structure of the dashboard. In the next lecture, we'll continue building on this foundation. Thanks a lot for watching, and I'll see you soon in the next lecture. Hello everyone, and welcome to this lesson. In this lecture, we are going to proceed with populating our dashboard and adding the metrics. The first thing we're going to do is add our metrics. Let's start by adjusting the layout by pressing Ctrl and selecting multiple items. You can shift and reposition them together all at once. Once that's done, let's proceed to our metrics. I want everything to fit perfectly in the allocated space, so I'll make adjustments as needed. That looks better now. From our pivot tables, we are going to add the metrics. The metrics we're going to display are the total ad, spend, total revenue, ROI, and the average click-through rate, CTR. Let's calculate these metrics. The total ad spend is equal to the sum of ad spend. The total revenue is equal to the sum of revenue. The ROI is equal to this. The average CTR is calculated as the grand total. The first two metrics, ad spend and revenue, are of type currency, while the average CTR is a percentage. Let's format the currency values and set the percentages to 2 decimal places. That looks good. Now, let's add these metrics to our dashboard. First, we'll create placeholders for the total ad spend, total revenue, average CTR, and the ROI. Let's slightly increase the size of these placeholders to make them more visible. I'll copy the formatting to ensure consistency across all the metrics. Next, we'll add text fields for the labels. Under Insert, we'll add text boxes for each metric. For instance, one text box will display total ad spend, another will show total revenue. Let's copy this and paste here to display average CTR, and this one to display the ROI. Let's position them neatly and format them uniformly. Now, let's populate the text boxes with the corresponding values. The first text box will show the total ad spend. The second text box will show the total revenue. The third text box will display the average CTR. The fourth text box will display the ROI. We'll set the font size for each text box to 36 and make the text bold for better visibility. I'll apply the same formatting to all the text boxes to maintain uniformity. That looks good now. So far we've successfully added the metrics to our dashboard. Everything is formatted properly and the layout looks clean. In the next lecture, we will add the remaining elements to the dashboard to complete it. Thank you, and see you in the next lecture. Hello everyone, and welcome to this lesson. In this lesson, we are going to proceed by populating and rearranging the various elements in our dashboard. By the end of this lesson, we'll have a functional and visually appealing dashboard. First, let's copy the charts we created and place them on our dashboard. We'll start by positioning one chart here and the second one next to it. Resize and adjust them as needed. You can increment the size slightly to ensure they are visible and properly aligned. The size and dimensions of the elements are up to you, so focus on creating a layout that is simple, readable, and visually appealing. Now, let's bring in the remaining charts. For example, place one chart in this section and another one beside it. Once all the charts are added, we need to make sure they are easily readable. Let's begin by increasing the size of the headers and legends to make them stand out. Adjusting these small details improves readability. Next, let's add data labels to the charts where necessary. This ensures that the important numbers are visible directly on the charts. For each chart, increase the size of the data labels slightly if needed. These labels are critical for understanding the data, so make sure they are clear. Now, let's add some colors to make the dashboard more uniform and appealing. Under the shape format options, add an outline to all the charts. Increase the outline width to give the charts a consistent and polished look. Make sure to use the same style for all charts for uniformity. Let's also adjust the font colors and make all the chart headings bold. This will help the text stand out. If you want, you can explore other formatting options like increasing font size or changing colors to match the dashboard theme. Next, we'll customize the slicers. To do this, go to the slicer settings and duplicate the slicer style. Rename it to something like custom, and under the formatting options, increase the text size to 22 for better visibility. Apply this custom style to all slicers. For some slicers, you can also increase the number of columns to 2 for better organization. Adjust the height and width of the slicers as needed to ensure they fit well within the dashboard layout. If a slicer scrolls because it has many items, make sure the height is appropriate and the scroll bar is visible. You can scale up the dashboard to match the overall dimensions of the screen for a more appealing look. Now that everything is in place, let's test the dashboard. For example, select a date from the slicer and see how it affects the metrics and charts. You'll notice that the data updates dynamically, showing the metrics like total ADI spend, total revenue, and average click-through rate for the selected region. The graphs and metrics adjust accordingly, providing a clear and interactive view of the data. One final point to consider is color representation. Choosing the right colors is crucial for making the dashboard visually appealing and easy to read. For instance, you can modify the chart colors to create a gradient or match the theme of your dashboard. Make sure the colors are clear and consistent with the other elements on the dashboard. Now we have a complete and functional dashboard with line charts, pivot tables, pivot charts, slicers, and all the essential components. The dashboard is interactive and visually appealing. You can try recreating this dashboard on a larger scale, adjusting the zoom level, and ensuring the layout covers more space for better visibility. Thank you for following along, and see you in the next lecture where we'll explore creating more customizable and interactive dashboards. Hello everyone, and welcome to this lesson. In this lesson, we are going to develop a sales and revenue growth dashboard. This dashboard will summarize information related to sales and revenue based on the dataset provided here. Let's first organize the data so it resembles real-life information. This dataset is not summarized like the ones we have used before. Instead, it contains thousands of rows, as is common in real-world scenarios. When dealing with data like this, you can summarize it into various formats and focus only on the necessary fields. For this example, we will present information about sales and total revenue for a shop or a chain of shops. Let's take a quick look at the dataset. We have the following fields: transaction ID, a unique identifier for each transaction; date, the date of each transaction sorted in chronological order; region, the region where the sales took place; sales channel, indicates whether the sale was through the online store, mobile app, or physical store; product category, categories such as electronics, pots, home and kitchen, books, health and beauty, or groceries; units sold, the number of units sold for each product category; unit price, the price of each unit; total revenue, calculated as units sold times unit price times 1 minus discount applied, the discount applied to the transaction. Let's format this as currency. Payment method includes options like credit card, cash on delivery, PayPal, or bank transfer. Now that the data is sorted, let's rename this sheet to Dataset and create a new sheet for the dashboard. Let's begin designing the dashboard layout. To start, reduce the zoom level to 30 for better visibility while designing. Next, let's create a layout for the dashboard. You are free to choose colors of your choice, but ensure they complement each other and maintain a professional appearance. For now, let's use this color scheme. Insert shapes to define sections of the dashboard. Add a rectangle to serve as the main container where all elements will be placed. Adjust its size and position as needed. Next, add another rectangle at the top for the title. This rectangle will serve as the title box, so ensure its height is slightly larger for better visibility. And another shape here for the slicers. Let's adjust the fills for these shapes. The main container should have a white fill, and the title box should also have a white fill. The title should directly convey the purpose of the dashboard while summarizing the information in a clear and understandable manner. For the title, let's write Sales and Revenue Growth Dashboard. Center the title, increase the font size, and make it bold to ensure it stands out. Adjust the alignment and size until it looks appropriate. This should be okay. Now that the basic layout is in place, we have sections for slicers, metrics, and graphs. This layout will serve as the foundation for the dashboard. We'll continue modifying it as needed to ensure it aligns well with the data we add. That's it for this lesson. In the next lesson, we will start organizing the data and populating this dashboard with the necessary elements. Thank you for watching and see you in the next lecture. Alright everyone, welcome back. In this lecture we are going to proceed by establishing our pivot tables and key metrics. Using our dataset, we'll create pivot tables to organize and summarize the data effectively. First, let's select the entire dataset. Once selected, go to Insert and choose Pivot Table. Select Existing Worksheet, since I've already created a worksheet named Pivot Table, where we'll place the pivot tables. Let's start with the first one. For the rows, we'll use date, and under values, we'll display the total revenue. This will give us the revenue for each month in the year 2025. The focus of this pivot table is on sales and revenue by date. Next, let's create another pivot table. Again, we'll use the existing worksheet and select a location. This time, we'll classify the data by region. Add region to the rows and total revenue to the values. This shows the revenue for each region. Now let's add another pivot table. Insert it into the existing worksheet and categorize it by sales channel. Add sales channel to the rows and total revenue to the values. This table shows revenue generated from different sales channels, like the mobile app, online store, and physical store. And this one shows the revenue for each region. We'll proceed to create another table, categorized by product category. Insert the pivot table, select the location, and add category to the rows and total revenue to the values. This gives us revenue details for categories such as books, electronics, fashion, groceries, and health and beauty, and much more. For this specific dashboard, we'll limit ourselves to these categories: date, region, sales channel, product category. Of course, you can create additional pivot tables and dashboards depending on the insights you want to present. For example, you can have separate dashboards focusing on campaigns, sales performance, or other aspects of marketing analysis. Now that we have the pivot tables, let's add the key metrics. Since we are focusing on sales, the first and most important metric is total revenue. To display it, ensure that all decimal places are minimized to make the presentation cleaner. Select the data, and using Control, you can adjust all relevant fields to 2 decimal places at once. The total revenue is equal to this. Let's also display the region, let's say top region and top category, which is the category which had the greatest sales. For the top region, sort the region data by revenue from smallest to largest. In this case, the region with the highest revenue is South America. For the top category, sort the category data by revenue. Here, the category with the highest sales is fashion. Now we have the key metrics: total revenue, top region, South America, top category, fashion. Remember, the metrics and graphs you include depend on what you want to present and the needs of your audience. For instance, a dashboard tailored for sales performance might prioritize revenue by region or category, while a marketing analysis dashboard might focus on campaign effectiveness. Finally, as a bonus, you can consider creating a multi-dashboard setup where each dashboard focuses on a specific aspect of the data, such as sales, campaigns, or product performance. That's it for this lesson. We've successfully created the pivot tables and established the key metrics for the dashboard. Thank you for watching, and see you in the next lecture. Hello everyone, and welcome to this lesson. In this lesson, we are going to proceed with the creation of pivot charts and slicers. Here we already have our pivot tables, and now we'll use them to create pivot charts and slicers. First, let's create the pivot chart for the first pivot table. This one is ready, and I'll copy it and paste it here. Next, we'll create a second pivot chart. For this one, let's use a clustered bar chart. Remember to choose your chart type wisely to ensure it is easy to read, understand, and effectively represents the data. Now, for the third pivot table, we'll use a pie chart. Let's select the 3D pie chart for better visualization. This one works well for the type of data we are displaying. Lastly, for the fourth pivot table, we'll use either a line chart or an area chart. Both are suitable for this type of data. I'll choose an area chart and paste it here. Next, let's add slicers. We'll insert slicers to filter data by dates, regions, sales channels, and product categories. Ensure all the necessary pivot tables are connected to the slicers. For each slicer, verify that only the relevant pivot tables are linked to avoid unnecessary connections. Now let's format the charts slightly. To improve clarity, remove the field buttons from all the charts. Under Pivot Chart Analyzer, you can remove these buttons as they are not required. At this point, we have our pivot charts and slicers ready. What remains is to organize them on the dashboard and include the metrics. We'll handle that in the next lesson. That's it for this lesson. Thank you, and see you in the next lecture. Hello everyone, now we are going to focus on adding our metrics to the dashboard. First, we'll add a shape to display the metrics. Set the fill color to white. This shape will display the total revenue. Format it appropriately, and for better visibility, let's change the color to something slightly darker. This is okay. Next, let's copy the formatting of this shape for the other metrics. For example, one shape will display the top category and another will display the top region. The choice of names for these metrics is up to you. Just ensure clarity. Copy the formatting to ensure consistency across all shapes. Now let's add the actual metrics. Using the dataset, we'll add a text box for each metric. Start with the total revenue. Insert a text box. We get the data from here. We then adjust its size and format it with the appropriate color. Gradually increase the font size until it looks clear and readable. Repeat the same process for the other metrics, such as top region and top category. Apply the same formatting to maintain consistency. Once the text boxes are ready, let's add icons to make the dashboard more visually appealing. Under Insert, we can add icons to the worksheet. For total revenue, choose an icon that represents money. For top region, select an icon related to location. For top category, choose something that represents a shop or product category. Place these icons next to the respective metrics and adjust their size as needed. Also, let's change the color of the icons to match the dashboard. Ensure the icons align properly with the text boxes. Make any necessary adjustments to the size or positioning of the text and icons to achieve a clean and professional look. Now that we have our key metrics displayed on the dashboard, we'll stop here for now. Minor adjustments can be made later if needed. In the next lecture, we'll proceed with adding the graphs and slicers to complete the dashboard. Thank you and see you in the next lesson. Hello everyone and welcome to this lesson. In this lesson, we are going to focus on adding charts and slicers to our dashboard. First, let's reposition some elements to ensure everything fits well. For example, if any shapes overlap, you can remove the shape, fill to keep only the text visible. This will help with positioning without unnecessary clutter. Now, let's move to the pivot charts. We'll start by adding a slicer. Place it in the desired location, adjust its size, and format it. Next, let's duplicate and update this style. You can change this title to something more descriptive. Increase the font size to ensure visibility. This should be okay. Now let's apply the style. Let's increase the height. Let me remove this. You can make this slicer to have 2 columns, or you can leave it like this. This height is okay. Let's increase the font size. Let's make it bold as well. This is okay. Now let's move to the pivot charts. We'll start by adding the first chart. Place it in the desired location, adjust its size, and format it. For example, update the chart title to something descriptive like revenue growth over time. Increase the font size to ensure visibility. Let's increase these as well. We can remove this. Let's modify the title's font color. This looks good. Let's also make it bold. Similarly, we are going to change the color of these bars. We then adjust the width of the bars by reducing the gap width. Right-click here, and under the Format Data Series option, we have this. This makes the chart more readable. Next, we'll add the second chart, place it efficiently to manage space, and update its title. For instance, use a title like Revenue by geographic region. Copy the formatting from the first chart to maintain consistency. Remove unnecessary elements. We don't need this. We'll add data labels instead. Make the labels bold and increase their font size for better readability. Then change the color of the bars and adjust the gap width for the bars to improve the visual appeal. Now, let's add the third chart. Position it on the dashboard and name it something appropriate, such as Revenue by Sales Channel. Then we format it, increase this font size, You can select a style from these as well. Let's adjust the chart colors to align with the overall theme. Add data labels. Ensure the chart is clear and descriptive. For the fourth chart, place it on the dashboard and give it a fitting title, like revenue distribution across categories. Format the chart title. Copy this formatting and paste it here. Let's change these fonts to black and also make them bold. Let's do it for all of the charts. Let's adjust the colors of the chart to enhance readability. After adding all the charts, you can refine their appearance. Use consistent color styles and outlines for all charts to make the dashboard more presentable. For example, add an outline to each chart and ensure the colors match the theme of the dashboard. Now, the charts are complete and the dashboard is starting to take shape. In the next lecture, we'll proceed with adding slicers to make the dashboard more interactive. Thank you and see you in the next lecture. Alright everyone, now we are going to add our slicers. We have already added one slicer and now we'll add the remaining ones on this side. These slicers are included in the pivot chart worksheet. Let's start with the date slicer. Position it carefully to ensure it fits well. Remember, we are going to have 3 slicers, so leave enough space for all of them. Once the slicer is in place, duplicate this style and adjust the font size. Let's set it to 20, which should be fine. Let's increase the height. We can modify the font size slightly. Let's try 22 and also make the text bold. That looks better. You can see that it allows scrolling, and if needed, you can also add 2 columns to the slicer for better organization. Let's make some modifications to the slicer's font style. Choose a font that looks better and more consistent with the dashboard. This one works well. Next, let's add the remaining slicers, ensuring they are uniform in style and size. Let's apply the same dimensions to the other slicers in order to make them uniform and appealing. This ensures consistency across the dashboard. Now, adjust the slicer's heights and widths as needed. If a slicer is ending at a certain point, you can make it 2 columns to save space and improve readability. Modify the colors to maintain consistency with the dashboard's overall theme. After slight adjustments to the width and alignment, the slicers should look much better. With this, we have completed our dashboard. The sales and revenue growth dashboard now includes the title, metrics, slicers, and charts. Everything is connected and dynamic. For instance, if you select a specific date in the slicer, the metrics and charts update automatically to reflect the data for that date. Similarly, if you select mobile app as the sales channel, it will display the revenue for that channel on the chosen date or range of dates. You can as well choose 2 of them. Here, for instance, we have the data for online store and mobile app. Here we have the revenue for each category and region, within this time frame, of course. You can also filter by region. For example, selecting Africa will show the revenue, sales, and category breakdown specific to that region. If a specific category, such as groceries, doesn't show any data, it could mean there were no sales for that category on the selected date. This concludes our journey through this project of dynamic marketing, analysis, dashboards using Excel. You've learned how to create dynamic and interactive dashboards, including adding slicers, charts, and key metrics. There's still more to explore in Excel, and I encourage you to experiment further with the tools and concepts we've discussed. One final note, make sure to make the dashboard even more interactive. For example, if you select the electronics category, the top region metric should dynamically update to show the region that sold the most electronics. Similarly, selecting mobile app as the sales channel should update the top performing category for that channel. These interactions can add more depth and utility to your dashboard. Through this course, we've covered how to align elements, style them, and create cohesive and interactive dashboards. I encourage you to practice everything we've done here to reinforce your learning. Thank you so much for watching and for going through this course. I really hope to see you soon again. Until then, please take care, study hard, practice, and I wish you the absolute best in your endeavors.